Welcome and hello. This is a video exercise in HEC RAS. And in this exercise, I'm going to be dealing with Chattanooga swimming is the title of the video. In this video, we will develop a river hydraulic model in the Tennessee River and evaluate velocities when the bathymetry is unknown. So what I'm going to do is create a few different profiles for bathymetry, run the model a few times, and then compare the results. So with all the exercises, I'm going to start from the beginning, File, New. Navigate on your computer where you want to save your project. Okay, and then click over here in the title window and then give it a title. All right, and then click OK. Okay, so I'm going to be using US customary units. Click OK. I'm going to start by opening up RAS Mapper and then importing a projection or setting the projection. This occurs in south central Tennessee. Let me go ahead and bring up the map here. This is the river here. I'll zoom in and take a closer look at this river, but just trust me, it is in Tennessee. And if I bring up the UTM zones, that is UTM 16 North. So then let's go ahead and visit the Spatial Reference webpage. I'm going to click on EPSG, and then I'm going to just type in UTM 16 North. All right, this third one here is what I've used before, so let's just go with that. It's going to be NAD 83 for the horizontal datum. And then scroll down a little bit and then click on the .prj file to download that projection. All right, so let's go ahead and minimize that. I'm going to open up my project file here and then just move that projection here. I'm also going to rename it. I'll call it projection EPSG. All right, minimize that. Let's go ahead and navigate to that projection file. There it is. Apply and OK. Next, what I want to do is download the terrain data. So I'm going to select USGS, and then I'm going to select latitude, longitude, where I specify the top left and bottom right coordinates of the location of interest. This is the location of interest right here. Say, for instance, we find ourselves in the Tennessee River and we are going to be swimming 2.4 miles downstream. And we're going to start here and then end sort of in downtown Chattanooga, I believe. Then this is the particular area. Using the latitude, longitude down here is my go-to method for figuring out where on planet Earth I am. So this is going to be 35 north, 85 west. All right, so once I have that data and I have it written down here in my notes, click on this button right here and then type in the latitude, longitude. And then for longitude, I'm going with a negative number representing the Western Hemisphere. That's the top left coordinate. I'm going to type in the same numbers for the bottom right coordinate and then click OK. I'm going to select elevation models. That's correct. And then query products. Now I'm going to select the 1 meter data, specifically this one right here. That's going to save to my project's terrain directory in a USGS subdirectory. So I'm going to click download and wait for that to download. All right, that downloaded fine. I'm going to go ahead and click close, and then let's load or import that GeoTIFF terrain that we just downloaded into our model. So I'm going to right click, create a new RAS terrain. I'm going to navigate to that file now, and here it is. Okay, I need to convert meters to feet, and then everything else looks good. It's going to be called terrain.hdf. In fact, let me go ahead and change that real quick. I'm going to name this read-only.hdf. Okay, so this is going to be sort of my base, but read-only sort of enforces the fact that I don't want to change it. I want to make copies of it if I need to change anything. Okay, now let's go ahead and click create. All right, that finished up. Let's take a look at that close. And then, yeah, here is the terrain data that we just loaded in. Here is the extent of it right here. Again, this is 1 meter resolution. Here is our river down here. I'm going to scroll in on the river, and then here is the location that we're interested in. And then based on the course map that is right here, we have the starting location. It is 4,100 meters upstream of this downstream street. So I'm going to use these approximate extents for the analysis in this model. If I need a reference point, like for instance, the topography is not good enough, I can always insert a web imagery layer. So if I click on like Google or Bing satellite and then click OK, then boom, there's that. So we have a number of bridges here. And then the end of the swim is at the downstream end, which is right about here. So this river pretty much matches up well with the terrain data. We can see that there's no bathymetric data. That's one of the hardest things that I've encountered when running these models is getting the bathymetry right. And since I don't know it, what I'm going to do is sketch out three different bathymetry options. All three options will be about 3 feet deep, but then each individual option will have a deeper section, left, center, and right, if we're facing in the downstream direction. So a good part of the remainder of this model building process will be to generate these three different terrains. The terrain that I've already created here is called read only. And I'm going to create three copies. One is going to be called deep left, deep center, and deep right to represent where in that river channel when facing downstream is going to be the deeper section. For the terrain later, I'm first going to just create a copy of the read only, which is going to be sort of my working terrain file. And then once I make certain changes, I can create clones for the deep left, deep center, and deep right. So just stick with me for a moment. Right click, clone terrain. I'm just going to call this sandbox for lack of a better term. And now I can turn off the read-only version, turn on the sandbox version. Now I'm free to start making edits in my terrain. All right, so let's go ahead and make some modifications. I'm going to scroll up to the upstream end right here. And then let me go ahead and sketch in a center line and then save that to the sandbox terrain. I need to make sure I'm starting at the right location here. And this is where the map layer would be helpful. Okay, so okay, I think it's right about here. Let me double check one of my references. Yeah, so the start is this green dot, and there's like a red roof house or building right here with another one just beside it. So it's right about here. 1 second. Yeah, this is that red roof building, I'm pretty sure. So let's just go ahead and start it right here. I am going to click on modifications, right click, add modifications. I'm going to be using a line, and this is going to be a channel type line modification. And then I'm going to call this river center line. Okay, we're ready to go here. Before I make the edits, I'm actually just going to toggle off the map layers. And then right here is where I started. So I'm going to start making single left clicks along the river center line, and then just pan over, continue this process until I'm to downtown Chattanooga. So this is the endpoint right here. I'm going to do a click and then how about a double click right here? All right, that is it. Now it's asking me to define that channel geometry, the modified geometry values. And I actually need to get a few other data points before I do that. So I'm going to click OK. I'm going to go and change that data a little bit later. The data that I want to get is the elevation. The downstream elevation here I'm seeing is 636.38, and that's actually the water surface elevation. That's not the channel invert. And then the upstream, we're looking at 636.47. So it was only a drop of 0.09 feet. That's very little slope, so not much current is my guess. I also want to get the slope of that line. When I click on that river center line, and then going to highlight it and then click on the profile button. All right, a 0.09 foot drop divided by, looks about 3,500 feet, let's say 3,300 feet is 0.000027. So I'll say 4 zeros and then a 3. So just rounding up a little bit. I will need that a little bit later when doing the assigning the downstream boundary conditions. What I'm going to do here when editing, I'm going to say that it starts at 633 is the invert elevation, which would be 3 feet below the current water surface elevation. And again, this is only for the sandbox modification. I'm going to make the invert of the river deeper when I make some subsequent modifications to the river channel. I'm going to click on the river center line, then select the center line. Oops. Okay, it's selected now. Right click, edit the ground line modifications. So this is that same dialog box that we had up earlier. Now I'm ready to make some edits. So like I said, the upstream elevation invert of the channel is going to be 633.1, and then we'll just say 633 at the downstream end. So it's just a 0.1 foot drop. For the modification method, I'm going to just say replace terrain values with the actual values here, these two values here. And then for the width, I'm going to, 1 sec, let me just go ahead and cancel that. Okay, I need to update this. This is not what I want. It's not nearly wide enough. So I'll click on the measure tool, and then let's just get the approximate width here of the channel. It is 291 units. So yeah, okay, so let's go back and make the edits. Then right click, edit once again. I'm going to say 350. We'll say a 2-to-1 side slope is fine. Let's see, 2-to-1. So, and it's like 3 feet deep. So we'll just say maybe 370 for the top extents width. All right, that should be good. Let's go ahead and click OK. And right here is the revised channel. This is the modified channel that we just created. Now what I want to do is create 3 more terrains based on this sandbox. So they're all going to start with this initial bed depth, which will be about 3 feet deep. After that, we'll add another modification to each of the 3 terrains. So from the sandbox, I'm going to go right click, clone terrain. I'm going to call this one left and then OK. And then right click clone. I'm going to call this center. And then the last one is going to be right click, clone, and right. Now I'm going to toggle off sandbox and toggle on left. Actually, let me start with center first. Okay. So I'm going to edit the center. And what I'm going to do is create a channel that's a little bit deeper in this main channel, but in the center location. So I'm going to expand that, click on modifications, expand. For center, I'm just going to trace over this center line directly. Okay, don't need control points. So center line, that looks good. This is from the first modification. I want to add a second modification. So let's go with add modification. Again, I'm going to use line and channel. I'm just going to call this center. And then, all right, we're ready to start editing. So let me zoom in here. Single left click to start. And then essentially, I'm just going to trace over this center line and double click. All right. Once again, I get this dialog box and I need to lower the elevation now. So we have 636 right here. The invert is 633. And if we wanted to make it 5 feet deeper, then that would be 628. So let's go 628. And then downstream of that would be, or I guess we can make this 628.1. And then the downstream end would be 628.0. Just leave it at that. The bottom width, let's go ahead and make that 70. So 70, let's go with the 4:1 side slope. And then let's see, 70, if it's 5 feet deep and it's 4:1, that's 20 feet. On both sides is 40 plus 70 is 110. So we'll just say 110 right there. Okay. All right, let's go ahead and click OK and see what that looks like. All right, cool. So we can see that this center part of the channel does appear a little bit deeper than the left and the right side of the channel. And that's all we want to do for our center terrain. I'm going to do the same thing for the left and right terrain. So let me go ahead and toggle on the left terrain next, and then modifications. Here's the river center line. That'd be nice to see. What I'm going to do is sketch another line that's sort of splitting the difference between the center line and the bank line. So let's go modifications, right click, lines, channel. I'll just call this left and then start sketching. So here, here, and then here's the final click. All right. As before, let's just go ahead and use the same numbers. That was 628.1 and 628. And then up here, we're going to go with replace terrain values, which is really the same thing as lower value. But okay, what did we use? 70, 4, and 110. Okay, that's good. And then the last one here is the right side. So let's expand that. Modifications, check out the center line, and then right click, add a modification, line, channel, I'll call this right, and then start editing. Zoom in a little bit here and double click. All right, that's the end. Let's go 628.1, 628. And then the width is going to be 70 feet with a 4:1 side slope and 110. Okay, click close, and then we can stop the edits and then click yes to save the edits. If I want to look at this last terrain we did, which was the deeper right terrain right here, then what I want to do is right click, move this layer to the top. So when I sketch a profile line, it's going to use this terrain data to look at. So let's go up to features, profile lines, and then just go ahead and click the edit pencil to add a profile line. Let's add a profile line. How about just right here? So a single left click and then a double left click at the end. Profile line 1 is fine. So I'll click OK. And then let's go ahead and check out what that terrain looks like. All right, so here's the terrain. I should have probably started it a little bit further. So 1 second, let me just modify that real quick. Zoom in here, then double click. Let me move this over. Okay, that should probably be good. Let's see what that looks like. Okay, much better. So basically we have the original 3-foot depth that was created in our sandbox terrain layer. And then for this deep right, we have a deep section that's, well, it's only 5 feet deep here, but we expect to have higher flows and higher velocities in this right part of the river. If I went ahead and looked at the same cross section, but for the left deep terrain. Then I can go ahead and load that up. Let me just toggle that off, toggle left on, and then I need to also move this to the top, I believe. Okay. Let me click on the profile line, click edit, and then check out what we have here. Okay, cool. So again, it goes down 3 feet and then 5 feet. And then in the center and the right part of the channel, it's just, again, about 3 feet deep. Okay, I should probably fix this right here, but it's all right. All right, let's go ahead and add some geometry in the hydraulics and get on with things here. So let's create a geometry. So I'll just call this base. We're only going to need one geometry, even though we will have multiple different terrains associated with it. In fact, as far as terrain goes, let's go ahead and just let's start with right as our first choice. And I'll click close. All right, so click on the geometry name, base, and then edit. I want to add a 2D flow area, which is this one right here, and perimeter is what I'll sketch out. This is not going to be a model where I investigate flooding, a levee breach, a dam break, anything crazy like that. I am using a 2D flow model, but that doesn't mean I need to include anything more than the channel. So this is a situation where I'm only going to sketch out the channel and sketch along the perimeter of the channel for this model. And double click to finish it. I'll call this 2D flow area and then click OK. Let's go ahead and just see what 100 foot looks like for the computation point spacing and click generate computation points. Okay, so let's see. Yeah, that's not quite enough. I'm going to go ahead and make the cell sizes a little bit smaller. How about 50? And then click generate computation points. Yes, override the existing. That looks good. So go ahead and click close. Here is our mesh. The only thing I need to add to the geometry after this is the upstream and downstream boundary condition lines. So here they are, boundary condition lines. And then I'm editing. Okay, so I'm just going to sketch from left to right. Single left click, double click. I'll call this boundary condition upstream. And then I need to make one downstream as well. So let me pan over, zoom in, and then just a single left click and then a double click. So I'll call that BC downstream. All right, so I'm going to stop the edits, click the stop sign, and then OK. Let's go ahead and add some flow data. So to do that, I'll go to Edit, Unsteady Flow Data. And for some reason, I'm not seeing the boundary conditions. I just have to open the geometry in the geometric data editor for me to be able to define the boundary conditions for some reason. So let's go ahead and open that up, click OK. All right, it's open and I don't need it though, so I'll click Close, Edit, Unsteady Flow Data. Boom, here are my boundary conditions. For the downstream boundary condition, I'm just going to use normal depth, and then as before, I'll type in that slope. I think it was 2.7. Okay. And then for the upstream boundary condition, I am going to use a stage hydrograph, and I'll use a 1 hour time step, and I'll set the simulation time just to use the simulation time of the plan, which we'll get to a little bit later. From the original terrain here, the water surface elevation was 636. So how about we do this? We go 635, and then we gradually increase over the course of a 24-hour period up to 638. Let's see what happens there. So I'll come down here to hour 25, 638, and then I'll just click off and then click this button to interpolate missing values. So that'll fill in the values there on a linear interpolation. Okay, so I'll click close. And then let's see, initial conditions. I don't need to do that. All right, so I'm going to go ahead and file save the unsteady flow data. I'm going to name this water surface elevation and then 635-638, just so I can know what the range of elevations are from the title, and click OK. All right, so I'll close that. Next, let's go ahead and run the model. So run unsteady flow analysis. Before I can do that, I want to go ahead and name the plan and then input some parameter data. So file, save the plan. I'm going to call this, we're starting with the right geometry. So I'll call the plan right, okay. And then right over here for the short ID. I'm going to toggle on geometry preprocessor, unsteady flow simulation, and post processor. For the starting date time, I think it'd be a nice touch to actually use the date of the race, September 28th of this year. So 28 September 2025. We'll just start it at midnight and end it at midnight, and then 29 September 2025. For the mapping output interval, I like to actually use a shorter time interval. Just makes for a better animation after we have the results. And then one last thing is the options. I want to go ahead and add a warm-up period. So computation options and tolerances. Click on the 2D flow options tab, and then in row 11 for initial conditions, I want to set this to, how about 6 hours? That should be sufficient. Okay. All right, I think that's everything. So let's do one final save and then click the compute button. All right, so that ran, that looks good. Before I look at results, what I want to do is change the geometry to use the center and then the left terrains, and then create a new profile, run those two other simulations, then we'll look at results. So to do that, I'll go back to RAS Mapper, I'll click on Project, and then Manage Layer Associations. Now for my base geometry, I now want to change this to center right here. Click on Close, then go ahead and save. To run the center model now, I'll click on the unsteady flow analysis. I'm going to save this plan as center because I know that the geometry file, this base, is now using that center terrain. So File, Save Plan As, instead of right, center. And then, yeah, I'll call this center as well. And then click on Compute. Okay, that looks good. I'll close that up. One last simulation. This is going to be left, which is what we see on the screen here. Project, manage layer associations. Our base geometry is going to use left terrain, and close. Save that. All right, and then one final plan, File, Save Plan As, left, and compute. All right, that finished up. Let's go ahead and click close. Let's take a look at some of those results here in RAS Mapper. So what I have on the screen here is the left terrain. That's what's highlighted. So let's go ahead and click on the results, specifically the left results. I'll expand that. Click on, how about water depth? So I'll toggle on the water depth. As you can see, the darker blue color represents the deeper flow. So that's sort of what we would expect to see there. I'm going to toggle off a few of these geometry features. Yeah, we don't need the grid. And then I'm also going to bring this left up to the top. So move layer to the top. Also, what we could toggle on is the velocity right here. So if I click on velocity, it looks like it's between 0 and 2 feet per second, according to the coloration here and the scale bar. And something else I can check out is the flow arrows. And then I'm going to click on the flow arrows right here. So if I zoom in, you can see the vectors. It does appear that the arrows in the left channel are a little bit longer and hence faster velocities in this left channel than in the center or the right, and that's because it's deeper. Now, let's get some actual numbers to this. And before we do, let's check out the particle simulation as well, because that's always cool to look at. Okay, so it's kind of hard to see. Let me modify the options for this real quick. So I'll increase the lifetime and increase the speed. Okay, so now you can see on the screen the particles of water flowing through the channel. I could change the colors, but let's just keep it with white, or rather, let's just turn it off for now. We already have a cross section right here. Let's go ahead and use that. So I'm going to click on Profile Lines, and then right click on the profile line. Let's go ahead and plot I want the velocity actually, so let me toggle that on. Okay, let's see if I got velocity as a choice now. Yep, velocity. All right, very cool. So what we see here is we see higher velocities. Okay, something's up with the curvature of the line is exactly what I'm looking for. This is essentially zero velocity, but I expect to see a similar pattern when we look at central and right. Okay, so let's go ahead and take a look at the velocity profile across the channel using these other results, the center and the right deep terrains. So I'm going to turn off the left results, collapse that. How about right? So I'm going to open up right, click on depth. Here we see the channel is now darker blue on the right side, which is what we expect. That's consistent with a deeper channel. I'm going to click on right and then move this to the top. So top. Now if I click on the flow lines, these are the static flow lines. Okay, here are the arrows. So yeah, definitely a little bit longer arrows where the water is deep, and smaller arrows where the water's not quite as deep. In fact, we can go ahead and toggle on that velocity layer. And then let's see, what's the range of velocities? 0.09, 0.14. Okay, yeah, that makes more sense. I'm not sure what number I was looking at before. because 0.17 feet per second, that's very typical for a river like this that's flowing but not particularly turbulent, definitely subcritical flow. But if I made my color ramp, for instance, between, say, 0.05 and 0.25, let's do that. So I'm going to just update the symbology of the velocity in this case. Click Edit. I'm going to go 0.25 and then 0.05, and then create the color ramp, and then click OK. All right. So that looks good. We have higher velocities right here in the right part of the channel because this is the deeper part of the channel. And this is the color ramp right here. So changing the color ramp gives us a little bit more better visual to see where the velocities are high in this river reach. And if I scroll down, we can see it's the same is true further downstream. Looks like the most activity is going on right up here, and that's probably because of the boundary condition. It just hasn't really found an equilibrium. All right, let's go ahead and take a look at that velocity profile now. I'm going to click on the profile line here and then right click, plot the velocity, which is what we expect. Now we have higher velocities over here in the right part of the channel. And like these are the actual numbers I'm expecting to see. Like I said, 0.08 and then 0.16. Now, in reality, channels are not typically deeper on the inside. Typically, if there's any curvature to the river, it's going to be deeper on the outside. There's going to be more erosion on the outside and more deposition on the inside. And hence, that's why meandering rivers like these ones with not much slope tend to continue to carve out in the outside reach direction. Okay, let me go back and check out the middle now. So here is the center. I'm going to toggle on, how about the depth? Okay, that looks good. Now let's toggle on the velocity. I'm going to go ahead and update the colors again. Edit. So 0.05 and 0.25 is, I think, what we used. So, okay. And close that. All right. So as before, now the high velocity is in the center of the channel. Then if I click on profile line and then right click on the line itself and then click on velocities, now we have the highest velocities in the channel taking place at that deepest part of the channel. So pretty much what we expected to see. Whatever I clicked on when I looked at the left deep channel option, I think I just goofed something up. But basically, this is the results we would have seen and the same typical values for feet velocity and feet per second when looking at the left channel as well. Well, that's it for this exercise. What I can conclude is that uh, knowing the bathymetric data of the river is really important to know exactly where the river is flowing the fastest. And if you happen to find yourself in a swim race in Tennessee River or anywhere else, then you can go ahead and send me that bathymetric data, and I'll go ahead and run the model and tell you where you want to swim.